title suggests, passive house and integrated project design do play a factor in this presentation, which you'll see as we go along. But yeah, thank you very much. And Stuart and I would like to share our experiences working on this 16-unit nonprofit seniors housing project that was completed earlier this year in Tillsonburg, Ontario. In 2017, I got a call from the folks at the Tillsonburg Nonprofit Housing Corporation. They're the client here. And they asked if, they told me about a program that they were interested in doing qualifying for, the Oxford County Build Better program, which was initiated by Oxford County with two objectives. One was to provide additional affordable housing in the county, and the other was to address their very ambitious climate action plan, so to reduce greenhouse gas emissions. And they came up with a funding formula that the applicants could acquire if they met one of two criteria, one being PH certification, the other one being net zero. After doing a feasibility study, we found that net zero was going to be the more feasible, more practical path, which is what we eventually did. So one of the recurring themes that came up, because these are seniors, was, okay, well, what's comfortable? What's a comfortable set point? So in the passive house world, we use 20 Celsius as the design set point. I live in a near passive house in Oakville, and my mother, who's a senior, thinks it's a piece of crap. She's always cold when she comes to my house. So I have some first-hand experience with this, but this was taken in her senior's residence, not far from where I live, and I was planning on staging the thermostat control, but I didn't have to, because when I got there, it was already at 26.5. And if she had a pair of channel locks there and could crank it another couple of degrees, she would, but it doesn't go any higher. So obviously seniors have different thermal requirements. So this is a fireplace that's on in the lobby from, I believe it's on from October 1st to September 30th. So something like that. The good thing is they don't use much cooling. They just like to recirculate damp, musty air in the summertime. So that's going to save. And that's the most overworked, that baseboard heater there is largely responsible for the global warming in Oakville, for sure, anyways. There isn't any snow on the roof, put it that way. But set point plays a big factor in comfort and in also energy consumption. So if you look at the example up above, at 20C, the annual heat demand for this project came in at 30 kilowatt hours, which is 33,000 kilowatt hours per year for heating. Well, as you go to 22, it now goes up by 19%. If you go to 24, it goes up by 39%. If it goes up to 26, up 58% over the 20C. So this is something that we had to struggle with as we were looking at sizing the PV system and what the overall energy situation was going to look like from a net zero standpoint. Okay, so the IPD project team listed on the right. I won't name everybody there, but to say that they were all awesome. They all came on board pre-building permit, but a lot of the architectural design was already advanced and they already had site plan approval. So our options were kind of limited as to what we could do. Nonetheless, everybody worked together pre-permit to sort of get the details in place that we needed to meet the net zero goal, and it was a really, really solid experience. It was my first IPD experience, and it was really fantastic. I'm really lucky and proud to have been part of it. This picture shows the raft foundation. The site was quite amenable to a slab on grade. This particular system is supplied by Legalett. It's an engineered slab with 8 inches of EPS on the bottom for R32, 8 inches of concrete. There's no thickened edge. It actually, they use a thicker slab throughout and reinforce where necessary, so there's no thickened edge on it. It's sort of a uniform depth slab. You can see the yellow heavy stego wrap there. That was the air barrier, continuous air barrier which flowed underneath and was obviously connected to all the drain pipes that you see there. The stego wrap is sandwiched between 2 4-inch layers of EPS. And one of the really cool things about this particular product is that it has an edge element, which is there's extra 4.5 inches of insulation that protrudes off the side of the raft assembly, that's the slab raft assembly, that's going to marry up with the wall insulation. So you really have continuous insulation uninterrupted all the way up. Thank you. Some of the numbers, 100% electric systems, 12,000 square foot building, 2.9 million final cost, which was about $244 a square foot. That's including the PV system. $17 of that was a PV. There's the summary on the assembly components. It's a fairly simple building, slab R32, walls R40, roof R80. First time that this particular GC had done this type of construction. We had a modest, but nonetheless ambitious target of 1.0 air changes per hour, and in the end we came in at 0.75, so they did a great job on the details. Fairly simple details as far as assembly goes, and again, they just paid great attention to it. They got some good guidance from some of the suppliers involved as well, and did a really nice job of connecting all the connections that needed to be connected. And finally, this is the above ground wall detail. Again, this APS product, 4.5 inches of EPS, also supplied by Legalett. There's a snap track system that installs. I'd worked with it on another project. Basically, it was really easy for the build team to learn how to use. They were able to order it with the already cut to size below the windows. It's the same thickness as the slab insulation edge, so there's a perfect marriage between the wall insulation and the slab insulation. And you can see the other details there, the zips sheathing connected to the air barrier. And as far as windows, and there's the building to the right, you can see that's with the strapping put on for the siding that was going to be put on there. They ended up with a facade of cement board, of fiber cement.